Okay, in this lecture, we will describe some mathematical part which is required to develop a absorber at particular frequency. In previous lecture, we have only given introduction about absorbers. The absorbers were used as detector, and these detectors were used to introduce voltage, and these voltages were correlated with the pixels intensity, and the pixels intensity we have used to develop imaging. So in that way we can say that absorbers have been used at terahertz frequency for imaging, and the signal was generated with dielectric resonator antenna which was developed at terahertz frequency. So similar to X-ray, the device under test, or for medical applications, the where we want to take the imaging, the part of that we keep in between dielectric resonator antenna and absorber. These we will be using in MIMO pattern, massive MIMO pattern, or in array format, and these array format will be in regulated way. As I already said that at X-ray, ionizing effect is there for the human tissue, which is dangerous. But at terahertz frequency, when we go for scanning using dielectric resonator antenna being developed at terahertz frequency and absorbers array developed at terahertz frequency, in between device under test is kept, or the tissue is kept, and then regulated RF energy is passed through. We can measure this image in three different patterns, as I already said in the previous lecture: reflectance mode, transmittance mode, or absorptance mode. Now we will see what is the correlation of these type of absorbers mathematically. But before that, there are three different structures of these absorbers. One is jamun shape, second is Dallenbach, and third is Salisbury. These are the three important structures being used so far to develop absorbers. Now, in this coming the outcome of the previous lecture, we have seen that incidence angle and shape of absorber, this was generally taken as conical, because lot of incidence angles, the advantage is there if we develop structure of absorber in conical shape as compared to cylindrical or rectangular shape. Now, for computing incidence angle or sensitivity or polarization insensitive, what we do, we keep theta and phi into specific range. First we keep theta is equal to 0, we fix it, and then we vary theta, we vary phi from 0, 10, at 10 degree step, 20 degree, 30 degree, 40 degree, and then compute absorptance. If there is no variation in absorptance value, then we will say it is polarization insensitive. And the formulation used for driving the absorptance is A is equal to 1 minus S21 whole square minus S11 whole square, or in other way we can say 1 minus transmittance minus reflectance. This is absorptance. Now the device or absorber which we develop, we want that it should operate in a meshed format, means the impedance must be perfectly meshed, and because we keep this absorber in free space, so the device which we have developed as absorber must resonate at perfect impedance so that maximum power transfer takes place. So we design the impedance of absorber equal to free space. Free space impedance is 377 ohm. In that we see if we work on reflectance or transmittance mode, so Z total is impedance of absorber, and we try to bring this impedance equal to 377 ohm, that is free space impedance. So for this we use formulation 1 plus S11 whole square minus S21 whole square divided by 1 minus S11 whole square minus S21 whole square under root complete. So this is how we try to get Z total as 377 ohm. There are few other parameters while we design absorbance. One is the fields are two types. One is H field and E field. In H field, we try to bring the T part as ampere per meter, that is A by M, and in E field we try to get voltage per meter as Tm. So these are the three important formulation we use in devising absorber. Then, as I said, there are two other parameters. One is refractive index, and the refractive index can be termed as N is equal to C upon V or sin I upon sin R, that is refractive index. So these fields T or Tm can also be termed as J. J is current density, and we try to get it proportional to intensity of the pixel. So J is proportional, directly proportional to intensity. One more enhancing parameter in developing or designing these absorber is we use SRR. SRR is surface ring resonator, or these can be T shape, it can be rectangular shape, it can be the circular shape. So different patterns for SRR being used, and to develop this SRR we need to talk about length of SRR, width of SRR, height of SRR, and D, the gap of SRR. So these T, thickness of substrate, and D, gap of the two part of SRR will get us the capacitance part, and the length of SRR will give us the inductance part. So basically we play with the value of C and value of L while designing SRR for a particular frequency. Now the best way is to compute SNR. If you get better SNR, it means your imaging will be definitely the high quality. So there are few important parameters while using these absorbers for imaging. We need to see that number of SRR are optimized. We need to see that absorbance is optimized. We need to see that SNR is optimized. We need to see that group velocity is what is required. And two important parameters which we have already discussed is absorbance, efficiency, and the most crucial is matching of total impedance. It must be equal to free space impedance. These are the few parameters while we use mathematical terms in designing absorbers. That's all. Thank you.